Hello everyone, good evening. So I hope you guys are ready for our today teacher class, which is teacher class number 3 for our subject physics. Right, so I definitely heard some of people has actually joining our teacher class before for the chemistry and biology. Okay, which is great. Okay, so I think our time is going to start right now. So let's get our class started. So today is our teacher class number 3 for the subject physics, and we are only focused on chapter 2 for our form 4, which is force and motion 1. Okay, and before that, I want to introduce myself. My name is Sun Wei. Okay, so here is my brief background about me. Okay, today I'm going to be your captain today. So my name is Sun Wei, and right now I'm taking a master degree in bioscience in UTM. Okay, so here is my teaching experience before I joined this learn.grow hub. Okay, so I have experience joining the UTM Mandarin class tutor, especially for the international students, and also been a learning facilitator in the international volunteering program. Okay, so today let's dive into world physics and experience the fun of learning. Okay, so before that, if you have any questions, just feel free to ask me. You can try to chat into the chat box below, or you can raise your hand so that I know you are going to ask me a question. Okay, right. Okay, all right. Okay, so before we're going to go to our contents today, so here is a brief introduction about the formula to get a full A+ in the joint SPN intensive camp. Okay, so basically, if you join our joint SPN intensive camp, you are able to. We are going to teach you about the contents about the physics, chemistry, and biology. And how inside this SPN intensive camp, you're going to be focusing on what we are going to talk. We're going to learn today. And also feel free to ask questions in the live chat. Okay. And if you are joining the joint SPN intensity care, we're going to provide you to a lot of the LNG question bank, which is the question banks that are created by us or the tutors here. And also we're going to provide you some the platform like Facebook and Discord so that you are able to ask a lot of questions in our private group and we'll be able to answer back about all your questions in 24 hours. Okay. So you want to know more about the information, you can try to look at our meeting chat right now. So our admin right now has given out a lot of information, and we're going to give you more information after the end of this session. Okay. Okay. Okay, right. So we are going to look at the first subtopic today. So we're going to look at the force and motion, right? Okay, so first, so basically force and motion 1 is quite a very large chapters. In Form 4, basically you have 8 subtopics. So I think within this 1 hour session, we're going to cover maximum will be like 3 subtopics, starting from linear motion to linear motion graph and go to the free form motion. So hopefully we're able to finish all within this 1 hour's limit. Okay, so firstly, 2.1 linear motion. So basically, firstly, you should know what is linear motion. So here, basically say that linear motion is a motion in a straight line, or basically in one direction. Okay, that's what we call linear. Oops. Okay, so this is what we call linear. Okay, so we are able to describe our linear motion based on different types of physical quantities. Okay, so here is the first pair of the physical quantity that you should understand the definition, and also the difference between these two, which is the distance and displacement. Okay, so here we have a distance and displacement. So I already make a difference in this table. So here is the definition of the distance. So basically distance is referred to the total length. So you see I have a keyword here, total length. So you know it's the length, right? So you know that your SI unit for length is the meters. So from here, you should also know that the SI unit for distance will be expressed in meter. Okay, so distance is defined as the total length of the path that an object travels. Okay, well, for the displacement, you will see that it will be the shortest distance. So here I emphasize here, there will be the shortest distance between an object start and the endpoint in a specific directions. So here is another focus that you need to pay attention to. There is a specific direction. So there are something that has a magnitude because they express a value, and also you have a specific direction. So you also have direction. Okay, so from here we can also differentiate distance based on the types and the physical quantity they are. So like distance is a scalar quantity. right? So I hope you know what scalar in your chapter 1, which is the measurement in your form 4, because it's the basics for all the physical quantity. You're going to learn in the SPM physics. So they are scalar, which means only has values, magnitude only m. Okay, for displacement, you should know that displacement has a direction and a magnitude. So displacement will be a vector. So vector quantity. So it has magnitude and also has direction. So here is the difference between distance and displacement. One is scalar, one is displacement. So in terms of the calculation, or how do we interpret based on the pictures from the question, here is how we tell them apart. So here I give it a similar scenario for both the movement of the objects. So here you see this picture. Let's say the object is start from the green start point. It moved to the yellow point, and then it moved back to the red point, which is the end point. So to calculate distance, we say that distance is a total length. Okay, there is a total length. So basically what you do is you're going to plot every values from this pictures. So basically the distance d will be equal to the total distance, the length, which is 5 meters plus 3 meters. So if you calculate, it will be 5 plus 3 will get you 8 meters. Okay, so must have a values and also have a SI unit, which is meters. Okay, don't forget to express your meters or your unit for the final answer of your calculation, because without the unit, we'll count your answer as wrong. So make sure you always put the correct unit at the end of your final answer. Okay, so this distance will be 8 meters. Okay, if I calculate displacement, I will get a different values if I compare to distance. So again, it's a similar scenario. The object moved from the green point to the yellow point and then move back to the red point. So how do we calculate displacement, which is S? So displacement is the shortest distance, right? The shortest. So basically you just find the straight distance, the linear distance between your starting point and your end point, which is starting point is here, your end point is here. So the shorter distance will be 2 meters. Okay, so I will just write 2 meters. Okay, so 2 meters is your magnitude, just value. It doesn't specify any specific direction, so you can try to add on the direction. So it's 2 meters to the right, because it's from start to end, right? So it's moving to your right side. So it's 2 meters to the right. So the right here is specified, but it's the specific directions of this displacement. That's why displacement is a vector. Okay, so this is the first, the easiest one, distance and displacement, and there's no formula yet for distance and displacement. Okay. Okay, so far, have any of you have any questions? So if you have a question, you can try to type in the chat box. Okay, so if you really understand about this distance and displacement, you can try to type 1 so that I know you have understand very clearly in the chat box. So anyone has question? Or you understand, you can just type 1 in the chat box. 1, right? Okay, so yes, okay. Okay, so I see all, they are typing 1, right? Because this is the simplest one, right? Okay, thank you for your replies. Okay, then we go to the next slide, which is the calculation, some real questions. Okay, so here is a question, right? So diagram shows a journey of a bus from city A to city D. So the question gives you the map. It's kind of like a map and the direction of traveling of this bus. Okay, so based on the values and also the information given for the questions, what is the displacement of the bus? Okay, so I'll give you 5 minutes or 3 minutes for you guys to try to solve this question. So if you know the answer, you can just type A, B, C, D into the chat box. Okay, so I give you 3 minutes to solve this question. Okay, so it's displacement, right? B. So I think Ideal say B, Aliyah say B. Okay, so a lot of students say B, which is 100 km. Okay, so yes, the answer is correct. The answer is 100 kilometers. right? So how do we solve these questions, right? So basically, you want to find displacement, right? So we know displacement is the shortest distance between the starting point and also your end point. So in this case, the starting point is A, the end point is D. So we're going to draw a straight line between A and D. Oops, this straight line. So that will be a displacement, okay? So you're going to find this A and D, right? So if you learn this in your mathematics, okay, about how do you solve the question revolving the shape, this side will be also 80 km. So to find S, the displacement, you have using the Pythagorean's theorem, which you'll learn this in your mathematics, right? So displacement square x square equal, so this side will be 100 minus 40, which is 60. Okay, so you want to find S, right? Your hypotenuse. So based on the so based on the formula, it will be S squared equals 60 squared plus 80 squared. So displacement will equal to the square root of the whole equation here. So you should be able to find 100 km. So the answer is B, correct? For those that can answer the answer correctly. Okay, so this question is just like this. Okay. So if I want to find distance, so let's say the question asks me to find distance. What is the answer if the question asks for distance? Okay, if the question asks for distance, how do you solve the answer? Where and what is the direction? Since it's a displacement. Okay, so for this question, you doesn't need to specify the direction. Okay, you don't need to put the direction here. Okay, because the question doesn't require you to find out the directions. But if you want to put the direction, the answer will be like north. It will be like this southeast. Because if you go according to the map, right? So from A to D, right? So it's like southeast. So you want to put direction, yes, you can put that, it will be southeast. Okay. So where was it? Okay, right. Okay, so I hope I can answer the question. Okay. So if the question asks you find distance, so what you should do is basically you just plus every values here, right? So you plus 100 plus 80 plus 40, and then you get 220 kilometers for distance. Okay, so distance is just easiest versions of displacement. Okay, right. So everyone can understand, right? Okay, so I will move on to the next physical quantities. Okay, the second pair of physical quantity that we can use to describe a motion will be your speed and velocity. Okay, so again, you should know what's the difference between speed and velocity. Okay, so here is the definition of speed. So speed is a rate. So here I put a rate. Remember, I have a rate of change in displacement. So speed paired with displacement. Okay, or I can define speed as a distance travel, not displacement. This will be distance. Okay, sorry, there's a typo here. So it'll be rate of change in distance for speed, or I can say it's a distance travel per unit time. Okay, so distance travel per unit time. So if I express in the form of formula, so speed equal your distance over time. Okay, so distance over time. So we know that distance is a scalar, right? So speed also becomes a scalar quantity. So it will be a scalar. Okay, so again, it has no directions, just only values, magnitude. Now for velocity. So velocity is a rate of change or displacement. Okay, so velocity pairs with displacement. Or I can say velocity is a speed of an object in a specified direction. Again, I put a specified direction here. Okay, so on here, I know that velocity must have a certain direction. So velocity will be a vector quantity, right? Because you have magnitude, the values, and the direction. So if I express it using the formula, it will be velocity equal displacement over time. Okay, so you see what's difference here is one is distance. The distance is for speed, displacement is for velocity. Okay, so that's the formula. And both physical quantities using the same unit, which is meter per second. So the unit will be meter per second, or we write ms. -1 or m/s. Okay, so that will be the unit for both physical quantities. So make sure you know the unit for speed and velocity. Okay, now the further advanced version, starting from speed and velocity, will be your acceleration. Okay, so what is acceleration? So acceleration is the rate, again, a rate of change in velocity. So they are used for velocity. To describe the change of velocity, we use acceleration. So you see here, we put velocity here. And we know velocity is a vector. So acceleration will also becomes a vector quantity because it also have direction and also with magnitude. Okay, so acceleration is a vector. Okay, and the opposite of the acceleration is what we call deceleration. So here is deceleration, okay, starting DE, okay, deceleration. So what is deceleration? Deceleration means when the object slows down. Okay, when the object is slowed down, which means your final velocity is lower than your initial velocity. So you speed up, you slow down. So we describe that motion as deceleration. Okay, so speaking of acceleration, deceleration, you should know what is the formula of acceleration. So based on the definition, you can try to derive the formula here. It says it's a rate of change in velocity. So change in velocity, right? So your velocity will be at the top of the fraction. So your velocity will be your final velocity minus your initial velocity. So it'll be V stand for your final velocity minus the initial U, okay, initial velocity. And we say the rate. So when you say something about rate, it must be something related with divided by time, per unit time. That's what we call rate. So in your formula, it will be V minus U divided by time. So that will be your acceleration. So this is another formula that you should memorize. A equal V minus U divided by T. Okay. And the final standard unit for your acceleration will be meter per second square. So there's a -2 here, -2, not -1, it's -2. -2 means acceleration. This meter per second is used for speed and velocity. So please don't be confused about these two units. Okay. Now, so because we know it's a vector for acceleration, so with vector, you will have positive values and negative values. So vector, it can be positive values or negative value. So how comes it can become positive and negative values? So the positive and negative symbol, the sign, represent the directions. So usually you get positive values if the direction is moving at positive, means forward direction. You get negative value means you are moving at reverse direction. Okay, this is why vector quantity you have positive and negative. It to specify the directions of the object they are moving. So from here, you should get that if we get -a, which is mean your acceleration is negative, it does not necessarily means it will be deceleration. Not always becomes deceleration, even though you get negative in front of the acceleration. Okay, why? Because you get negative, it may be because there's a reverse, means the object is moved at reverse direction. Okay, so when everything will be in reverse direction, your answer will get negative. Okay, so you will get negative values. Okay, so it's not always because deceleration, even though you get your answer is negative. Okay, so how about if I get the acceleration equal to 0? So if you find the answer acceleration equal to 0, no acceleration at all, which means the object is moving at constant velocity. You are moving at the same velocity, uniform velocity. That's why there's no change in velocity in time. So there's no acceleration. Okay, so this is how we describe the object using deceleration. Okay. Okay, so far does anyone have any question regarding to the speed and velocity as well as acceleration? If you have a question, you can try to type in the chat box. If you have no question, just type 1 so that I know you understand completely. Okay, type 1. Okay, so I saw the reply from Alea. Good. Okay, so let's say 1. How about the other people's? Okay, so Ramina also say 1. Okay. Right, so far it's okay, right? For acceleration, right? Just the surface of the chapter 2. Okay, so let's say 1, then we think we can move on. Okay, so here is some question regarding to the velocity and speed. Okay, so here, a car travels at a constant speed of 55 kilometers per hour for 5 minutes. Calculate the distance traveled by the car. Okay, so the question asks us to find distance. So A, B, C, D, right? So you can try to solve the question and give me your final answer in the chat box. Has anyone found the answer? So answer is C, 425 kilometers for Alia. Okay, so let's wait for the other students' answer. Is it A? Ravina say A. So here is a different answer, right? Okay. C or A. Okay, so Alia, Sabrina say A. Okay. So Eddie. So another student say C. So here is a different answer, right? Okay, so A or C, right? Okay, so let's calculate together. So you want to find distance. And the question gives you the information of the speed and the time, right? So always when you see question about calculation, firstly, what you should do is you try to extract all the information from the question, right? So extract all the information, right? So the question gives you the speed, V is 85 km per hour. It gives you time, T for 5 minutes, and you want to find what distance, D. Okay, so and then the second step will be to try to find the formula that are related to all the physical quantity that you list out based on the question. So what formula they have speed, time, and distance will be your formula of speed, right? V equal distance divided by time. Okay, so then you substitute the value inside, right? So your speed will be 85. D is what you want to find. Now the T here. So T, 5 minutes. It's minutes. If you look at the unit for the speed, it's kilometer per hour. So you see there are different units, right? So when you see a question has different units, you need to convert into similar unit. Then you put it into calculation. So here is 1 hour, this hour. So you can try to convert minutes to hour. Okay, so minutes to hour, basically to convert minutes to hour, you basically just do divide 60 because 1 hour has 60 minutes. So minutes to hour, you divide 60. So 5 divide 60, which basically you get 0.083 hour. Okay, then you put it into your formula. So with 0.083. Okay, so distance equal 85 multiply 0.083. Okay, so you should get 7.08 meters because the distance is a length. So the unit will be meters. So if I round off, you get 7.1 meters. Okay, if I round off, so your answer should be A, 7.1 km. Okay, not C. It's not C. Yeah? Okay, why you get C is because you just multiply 85 with 5, right? So you multiply 85 with 5, right? That's why you get C. Okay, which is not correct because this is minutes, unless this is 5 hours. If this is 5 hours, you can just multiply directly. Okay, so the answer is A. Okay, remember, convert back to the standard unit first before you do any calculation. Okay, check the unit. Okay, check the unit. It's just a minor mistake, right? I know, but it will cause a very strong impact for your final answer. Okay, right. So Alia, okay. So make sure you know the unit is correct. Okay, right. Now I have a second question about acceleration. Okay, a bicycle moves with an initial velocity of 3 meters per second, a final velocity of 4 meters per second, and an acceleration of 0.5 meters per second squared. What is the distance traveled? Okay. Okay, right. So how do we answer this question, right? Okay, so you see that this question gives you initial velocity, u, You give final velocity v. You give acceleration a. You want to find distance travel, distance or d or s, right? So how do you solve this question? So you see, so far we haven't learned about the formula about these four sets of physical quantity because you have to use another formula to solve this question. Okay, so this we're going to discuss at the later part about how to solve this question. So the answer is D. Okay, we're going to discuss how to solve the question later on because there's another formula or equation that will help us to solve this question, which is the linear motion equation. The four equations they need to memorize. Okay, we discuss that after. Okay, so we get it after that. After a few slides later, we're going to go back to this question. Okay, so because so far I didn't see any one of you have answered the question correctly. It's not C, it's not D. Okay. Okay, all right. Okay, need to go back here. Okay. Okay, so we're going to look back to that. We're going to go back to that question later on. So before that, so let's see the terms to describe motion. Okay, the scientific terms, also keywords that we're going to describe a motion. Okay, so here I make it in the table. Okay, now here, let's see what does it mean. So this is very helpful when you're looking at the question because some questions like to use different type of terms to describe the motion of an object. Right, so you see the question have a word about uniform or constant velocity, right? Uniform or constant velocity. So what does it mean when the question say you have uniform or constant velocity? Okay, so based on what we learned, like the velocity, the speed, acceleration, we can define uniform and constant velocity means there is no acceleration. Okay, so this is what I mean, right? Uniform constant velocity. So when the question say about uniform constant velocity, it means there's no acceleration. So you should know that A should become 0. Okay. Now, if the question say they have a terms about 0 velocity. Okay, you say 0 velocity. There's not change of displacement. Okay, so what does it mean when you have a zero velocity? Means there's not change of displacement over time. Okay, okay. So this means that there's no movement. Okay, at rest. Uniform. Yeah, rest or stationary. Okay, 0 velocity because v equals 0. Okay, which means it's not moving at all. It's at rest. It's stationary. Okay, so the question say about increasing velocity, which means v increasing over time. This means this has an acceleration. You are speed up. Okay, acceleration, which means your a, the value of a must be bigger than 0. It's positive values. Okay, it's acceleration. Okay, so opposite, if the question has decreasing velocity, right? Decreasing velocity means v decreasing over time. This means you are slowing down. So it's a deceleration. So if you calculate your a, you should get a value that are negative, which is more than 0. Now, sometimes the question say negative velocity, okay? Negative v. So how can velocity become negative? So negative v means you are moving at uniform velocity, but at reverse direction. Okay, because negative means you are moving at backwards. Okay, so that's why we have a reverse direction here. Okay, so negative acceleration. Okay, so negative acceleration, it can be two things. It can be deceleration, which means you are slowing down, or it can be acceleration, but at reverse direction. Okay, it may be moving at backwards. but it's accelerate. That's why you should get a negative acceleration. Okay, so negative means two things here. It can be velocity decreasing over time, which means slow down, or if moving at reverse direction. Okay, now constant acceleration or uniform acceleration. Okay, so uniform acceleration or constant acceleration means your acceleration at a constant rate. Okay, so your A is constant. Your A value of an A is fixed. Okay, so this then apply with your uniform or constant deceleration. So you are decelerate at a constant rate, or you can say your velocity is decreasing. Okay, it's decreasing at constant rate. Okay, so you are decreasing. That's why you get deceleration. Okay, acceleration means your velocity increasing at constant rate. Okay, so here is a very useful terms. Okay, so you should know what does it mean, so they know how to solve the question, especially for your paper 1 question objective. They like to use a lot this kind of terms. Okay. Okay, so far, have any of you have questions before we move forward to the ticket tab? If you have no question, just type 1. One. Okay, so I saw the reply from Ravina. Yes. Okay, but okay, so no question for Ravina. Okay, then we move forward. Okay, so go to the second part about linear motion, which is the ticket tab. Okay, so firstly, you should know what is ticket tab. So the ticket tab is basically used to analyze the linear motion of the objects, right? So it's a way that how we integrate the linear motion of the objects. So usually you will see a tab like this, and you will see there's multiple dots on the tab. So you must remember the distance or gaps between two adjacent dots is what we call tick. Okay, this is the space here we call tick, and one tick will be always 0.02 seconds. Okay, this is something that is very important that you need to memorize. One tick takes 0.02 seconds. Okay, so so here is how we analyze ticker tape based on the distributions of the dots on the ticker tape. So let's say I have two different ticker tape. I have ticker tape A, I have ticker tape B. Okay, and they are moving at this direction as pointed by this arrow. Okay, so how do we read the ticker tape, right? So the movement of the tape is from left to the right. Okay, so the beginning of the tape that it must be read is starting from here. So this is the way you need to read. You read from the tip of the arrow to the tail of the arrow. So you must be read from right to left. This will be the first dot. Okay, so right to left, and therefore this will be the last one. Okay, so now you look at the distance between each dots. Okay, so you see the dot is uniform. They are not changing. So which means this object is moving at constant speed. Okay, because there's no changing between the ticks. Okay, so since go be the ticker tape B, you see ticker tape B, the distance between each dots is still the same. So again, they are moving at the same speed. But if I compare ticker tape A and ticker tape B, I can say that ticker tape A has the faster rate, has the faster speed when compared to the ticker tape B. Okay, because the distance, the further the distance between two consecutive points, the further the points are away, the faster the speed of the motion. Okay, so this one is very important. So you need to pay in mind. Okay, so the further distance, the faster the objects. So that's why ticker tape A is moving faster than ticker tape B. Okay, so this is how we read. Now, let's say if you don't have a uniform distributions of dots. which means you have a change of speed over time. So like in this case, the distance between two executive points increasing. Okay, so the distance between the point increasing. So which means your speed is increasing. Okay, when your speed increasing, that will be acceleration. You're moving faster. Okay, this is V increase. So it's an acceleration. So your A will get positive value. Okay, so if the distance between two executive points decreasing, okay, it becomes smaller and smaller and smaller, which means your speed is decreasing, V decrease, so you get a deceleration. So your A variation is smaller than 0. Okay, so it's deceleration and acceleration. Okay, so this is a basic that is an introduction about how do we analyze ticker tape based on the distribution of dots on the ticker tape. Okay, now if you go to advanced level, you're going to know how do we calculate based on the ticker tape. Okay, so here is example of ticker tape. Okay, that we need to calculate. So usually question will just give you one single ticker tape and they give you the distance between these two dots first. Okay, at one end and another end, you give another information. And it also give you the direction of the motion. So how do we calculate the acceleration based on this ticker tape? Okay, so first thing you should know which one is the starting point, which one is your end point. So the direction of motion move from left to right. So it's moved here. Okay, move to right. So this one, the 1 cm will be your first regions. Okay, the first region. Well, the 3 cm here at the end of ticker tape will be the last region. The last one you need to read. So first region means you have an initial velocity. So this will be describing for U. Well, the last one we're describing for V, your final velocity. Okay, so how do we calculate? So we know that velocity or initial velocity U equal displacement divided by time. So it must be have a distance, a length, divided by the time. So the length is given based on this question is 1. Okay, how about the time? Okay, so before that, we mentioned about 1 tick equals 0.02 seconds. Now, here we're going to apply here. So it's 1 tick only, right? It's 1 tick, the distance for 1 tick. So which means it's 0.02 second. So divide by 0.02 second. Okay, so if 1 divided by 0.02 second, you will get 50. Okay, and it will be cm per second. So why cm? Because the question gives us the unit in cm. Okay, so this is my initial velocity. Now, same goes with your final velocity. So v, your final velocity, equal to the length 3 divided by the time. Again, this is 1 tick, which is 0.02 second. So 3 divided by 0.02 second, you will get 150. Again, the unit will be same, cm per centimeter per second. Okay, now you want to find acceleration, right? So we know the formula acceleration equal v minus u divided by t. Okay, then you put it inside. So your v is 150. Now your u is 50. Now, what is the time here? The total time. Yeah, to find total time, you need to find how many time has changed between your initial velocity and your final velocity. Okay, so how we do it is we calculate how many ticks are difference, how many ticks between your initial and your final velocity. Okay, so so we count like this. So we jump when we count. So like with this 1, this means 1. So we jump on this tick to this tick. So it's 1. So there's a change of 1 tick right now. Now 2, 3, 4, 5, and then 6. So you should have 6 jumps. Okay, it means there are 6 ticks difference between your initial and your final velocity. Okay, so it's 6. Now, so 6 is just the number of ticks. And we know each tick has 0.02 seconds. So you multiply 0.02 seconds, you get the total time. So you should get 0.12 seconds. So that will be the total time for the change of the velocity. That's why you can put here, this will be the values of your t, 0.12. So if you calculate 150 minus 50 divided by 0.12, you're able to get 833.33. Okay, the unit will be cm again because the question gives us cm. So I make it cm per second square. So there's a square, -2, because this is an acceleration. Okay, so this is the way that how we calculate the acceleration based on the ticker tape. Okay, so you need to keep in mind about this, the way that we calculate. Okay, now here is an example question about the ticker tape calculation. Okay, the diagram shows a ticker tape for a movement of a trolley like this. Okay, if the frequency of one tick is 50 hertz, okay, what is the acceleration of the trolley? Okay, so you guys can try to calculate first and give me your final answer in the chat box. Okay, so so how do we calculate for these questions? Okay, so here is a start point. Here's an end point. Okay, so you read this first. And then you go to the end here. So this will be tell you the information about your final velocity. And this will give you the information about your initial velocity. Okay, so you can calculate the velocity respectively. So V will be equal, the final velocity equal 4 divided by the time for one tick, which is 0.02. Okay, so 4 divided by 0.2. You get 200. Okay, so let's go with initial. Okay, so initial U equal 1 divided 0.02, which we should get 50. Okay, then we find the total time. They need to divide. So the total time will be 1, tick, 2, 3, 4, 5, 6. So it'll be 6 ticks, right? Okay, so it'll be 6 multiplied 0.02. Okay, where you get 0.12 second. Now you can calculate acceleration A. A equal V minus U divided by T. So V is 200, your U is 50, and then divided by 0.12. Okay, so we get, the answer is not here, right? Okay, you get 1250 meter per, not meter, cm per second square. Okay, so I think there's no answer here, right? Maybe it's a typo. This one should be 1250. Okay, so your answer should be 1250. So has anyone calculate the same answer as me? Has anyone calculate your answer as 1250 cm per second? Okay, so anyone get the answer? Why not 7? So you should get 1250, right? So I think it's typo here. Why not 7 for Ravina? Okay, because you are not okay, you get 7 is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. How do you get 7? Okay, why is not 7? 7. Okay. Okay, let me clean all first. Okay, you calculate the time, the ticks difference, right, between initial and final. So we calculate by 1 jump. This is 1, right? 1, 2, 3, 4, 5, 6. So it should be 6. 6, not 7. So it'll be 6 times 0.02. So get 0.12, right? Not 0.14. Okay, so it's not 7 intervals. You are not minus 1 based on the total number of ticks. 1, 2, 3, 4, 5, 6, 7, 8. Because there's 8 ticks, right? 8 dots. So your 8 dots, you don't minus just 1, becomes 7. You should draw the jump like this. And then you can really count how many times the ticks difference between your initial and your final velocity. So it should be 0.12 seconds. Okay, for Kyler is 0.12 seconds. It's because there's six ticks difference. Okay, not just -1, not 8 ticks, then you're -1. Okay. Okay, so your answer should be 1250. Huh? So sorry for the typo here. It's not 1500, it's 1250. Okay, so the time's almost end. Okay, so okay. Then we continue to the ticket chart, which is more advanced version for your ticket tape, right? Basically, you have a long ticket tape, and then we cut it into a similar number of dots, and then you put it into a chart. So this is a ticket chart, because there are same thing that we're going to analyze the ticket chart. So the first step, again, we will look at the ticket chart. You look at the first tape and your last tape. Is all the information you need. Okay, so first tape give you information of your initial velocity, right? So to find initial velocity is the length of your first tape divided by the time. So again, to find the time is to calculate number of ticks in this chart, in this tape. Okay, you should get 1, 2. Okay, so you get 1, 2, 3, 4, 5 ticks per tape. So there are 5 ticks per tape. So you put 5 and then you multiply 0.02 because each tick is 0.02 seconds. So there are 5 ticks, is 5 times 0.02. Okay, so your tape length, let's say, is 2. So you 2 divided by 5 times 0.02. So this is how you find your initial velocity. Now, same thing apply with your final velocity, which is your second step. Again, V equal the length of your tape. In this case, is 10. You divide by the ticks times 0.02, which is 5 ticks times 0.02. Okay, so you'll get your V value. Okay, then your third step, find what is the time changes, right, between your first step and your last step. Okay, so you can do the jumping method that we do just now. So you are jumping from your first tape to the last tape. So you have 1, 2, 3, 4. 4 jumps. So there are 4 tape difference. Okay, or you can use the formula number of tape in the chart -1. You can do that as well. Okay, and then 4 is just the number of the tape. They are different, but it's not time. To convert to time, you need to multiply the number of time per tape. Okay, we know that the number of time per tape is 5 times 0.02 because you have 5 tips and each tip has 0.02. So this is a time per tape. So you can put here, so 4 multiply 5 multiply 0.02. This will help you to get the number, the total time. Okay, so after you get all the information for your time, initial velocity, and final velocity, you are able to calculate your acceleration using the similar formula A equals V minus U divided by T. Okay, so you see you are using the similar method as the ticket tape. Okay, so here is an example question about how do you calculate for the ticket chart. Okay, so a trolley is pushed down a slope. So the diagram above shows a ticket tape chart that shows the movement of the trolley. Every section of the tape contains 10 ticks. If the ticket tape timer produces 50 dots per second, determine the acceleration of the trolley. Okay, so let's say this is a paper 2 question. Okay, so you need to calculate what is the acceleration. So you guys can try to calculate the acceleration first. Okay, and type in your final answer in the chat box. Okay, type the values of your final answer in the chat box. Okay, after that, we're going to discuss together about what is the answer. Okay, so if no answer, I'm going to show the working solution. Okay, so again, so first thing you can look at is you look at the U, the first tape, and the last tape. Okay, so firstly, we can calculate the initial velocity from the first tape and your final velocity from the last tape. So the first tape U equal the length of the first tape, 3, divided by the time. So the question will tell you that you have 10 ticks. Okay, so it's 10, number of ticks 10. And each tick is 0.02 seconds. So 10 ticks means you have 0.2 seconds. That is the time for 1 tape. So divide by 0.2. Okay, so 3 divided by 0.2, you get your initial velocity will be 15 cm per second. Now, same goes with your final velocity. So it's 8 divided by 0.2. So you get 40 cm per second. Now, what is the time difference between the first and the final velocity? Okay, again, you can calculate the number of jumps. So 1, 2, 3, 4, 5 jumps. Okay, so there are 5. And multiply the time for each take. So each take takes 0.2 seconds. So it's 5 times 0.2. So 5 times 0.2, you get 1 second. So that's the time difference. Now you can calculate acceleration. A equal V minus U divided by T. So your V is 40, your U is 15. Then divided by 1. Okay, then you should be able to get your final answer as 25 cm per second squared. So math rate is -2. So that is how you solve the question. Okay, so question like this in your paper 2 will around 3 marks. Okay, so this is how we solve this. Okay, so anyone have a question about this working solution? Anyone still have confusion about this? If no question, just type 1. Well, right, okay, so I get a reply from Alia. Okay, good. Okay. Okay, same go with Ravina. Okay, all right, so this is how you get the answer, right? So you should be able to find out the similar answer as mine. Okay, so based on time constraint, we are not able to finish 1.1. Okay, so because right now it's already 9:43. Okay, then we go to our final slide, right? So right now it's a Q&A session. Okay, so if you have any question, just type in your question in the chat box or raise your hand to ask question. Okay, if no question, again, just type 1 so that I know you have no question at all about our session today. Okay, again from Ravina, no question, right? Okay, great, awesome. Okay, so we're going to end our session right now. Okay, right. So before I end my final session, here is the final booster for you guys. Okay, so right. So we are still need 2 days left. Okay, 2 days left for our joint SPA intensive exam. Okay, our joint SPA intensive exam will be happening on this Wednesdays, right? 2 days after. Okay, so in this it will be take 45 days total before you have your final SPN. Okay, we are going to cover in SPN biology, chemistry, and physics, and they are all coming from different experienced teachers, of course. And then we'll be including a lot of there are a total of 15 live sections, right? So basically the 1 session per 1 or 2 chapters for each subject. And also we have Q&A sessions as well. And also, if you are able to enroll our this intensive camp, we're going to include all the tropical express notes. So they're notes per topic. Okay, and also we have the SPM format question banks. Okay, and our question banks will be strictly based on the SPM formats. Okay, we'll be including section paper 2, paper 1 as well. Okay, so paper 2 including section A, section B, and section C. And of course, you are not able to attend our live intensive camp. We're going to send you the recording for all live session to you by the email as well. And also you get a chance to consult with us, the tutors, in exclusive Facebook group and Discord. Okay, so you have any question regarding to the subjects, you can try to contact us. If we are free, we are able to reply you immediately about your questions. Okay, so if you are very interested about our eCamp program, please contact WhatsApp to us by using this telephone number 01165352622. Okay, 01165352622. Okay, for our 45 days for job experience intensive eCamp.